Hello again. This is the second video for the second part of section 4.2 for calculus class. In the first video of the second part, okay, we're talking about product rule in section 4.2. We're talking about product rule, did a couple of videos for that. In the second part, we're talking about the quotient rule. So this is the second video for quotient rule. And it's a tougher example. You got to go through a little bit more algebra and just kind of work your way through it. That's what makes it tougher. That's the only thing that's going to make any of these problems a little bit tougher. So, given this function f of x, we're going to find the derivative of it. Our function is a fraction, so we have to use the quotient rule. All right, so quotient rule says we take the derivative of the numerator. So this whole thing right here is the numerator. So we're going to have negative 3x to the negative fourth minus 4x cubed. That's the derivative of the numerator. We're going to multiply that by the denominator, x to the fifth plus 2. Then we go minus the numerator, x to the negative third minus x to the fourth, multiplied by the derivative of the denominator, which is going to be 5x to the fourth. All of this is being divided by the denominator squared. All right. So now, that's the quotient rule being applied. Got everything in there. The rest of the work is just algebra, combining some like terms. So, in the first term, where we did the derivative of the top multiplied by the denominator, we have some FOIL. We need to do this multiplication here, and we need to do the positive 2 multiplied by these two terms also. We're just doing FOIL. So, we're going to get a negative 3. X to the negative fourth times x to the fifth. You add the exponents, just gives us a negative 3x. Then we got minus 4x to the eighth. Now we're going to multiply 2 by these first two terms. That gives us a minus 6x to the negative fourth minus 8x cubed. That's that FOIL. Then we are subtracting. We've got some distributive property here. Got to multiply those things. So 5x to the fourth times x to the negative 3. You add those exponents. We got an x to the first power, but it's minus 5x to the first. And then we're going to have a negative 5x to the eighth, but we're subtracting it. So it becomes a positive 5x to the eighth. All of this is over our denominator squared. All right, let me bring this up a little bit. And so now, in this numerator, we have some like terms. Same variable, same power of the variable. So like terms here. We got an x to the first term, and then we have another one right here. So negative 3x, we're subtracting 5x, we got a negative 8x. Other like terms, we got an x to the eighth, and we got another x to the eighth over here. So negative 4x to the eighth, we're adding 5x to the eighth, that gives us a positive 1x to the eighth power. Then we got these x to the negative fourth there, and that's the only one of those, so minus 6x to the negative fourth. And we also have an, wrong one. We also have an x to the x cubed function, so we got a minus 8x cubed over our denominator. So like I said before, the only thing different or more difficult about this one is just we're dealing with some negative exponents. The terms get kind of weird, but you just go step by step and you follow the process. You're just doing some distributive property. You've got the rules of exponents. It's all normal stuff. It's just kind of get some weird results, some numbers and exponents that you're not used to dealing with. So we basically have our answer. I'm going to clean it up a little bit. Normally, when we have all these different powers of the variable, we start with the highest power of the variable. So in this numerator, we got an x to the eighth. The next highest power is that x cubed. We have a negative 8 of those. Then we have x to the first minus 8x. And we got that negative 6x to the negative fourth. So I'm going to write this as minus 6 over x to the fourth. Now you're thinking, oh, wait a minute, Mr. Johnson, you can't have a fraction and a fraction. It's all right. It's not a big deal. So we're just going to leave it. It's better than leaving it as a negative exponent. and over the denominator squared. There are no common factors. There's nothing that we're going to factor out. We are done, except for I forgot to put that little prime on that. There is the derivative of our original function. All right, so like I said, it's not much more difficult, but you just get some weird results. But this is the quotient rule. That is all. There is another example I'll put up here that requires a little bit more challenging thought to it, sort of. When you go to find the derivative of this, when you find the derivative of the numerator, our numerator is a product. So you're going to do the product rule inside of the quotient rule. Go ahead and give it a shot, and let me know how you do. Bye.